next we have Dr. Prasad Burra, VLS Prasad Burra. He is a professor from KIF University. Guntur, right, Prasad? Yes? Yes. Prasad got his PhD from IISc. He is into a lot of bioinformatics and computation, biochemistry kind of work. And he is going to talk about a recent aspect that we unraveled. Most of it is not published. It is available as a bioarchive preprint. So Professor Prasad Burra, please come. Thank you.
I'm a spectral biologist from IISc, molecular biology. Before that, I was at the University of Canada. Wherever some idea is needed, I generally carry it with those things. So currently I'm working on a new methodology in vaccine design and in nucleotide drug design aspects. And also I'm also into healthcare products. So around 5 areas I find looking for some investments, things like that. And the healthcare thing is how Ayurvedic Marna Chikitsa based things can be used to develop chapels which automatically take care of the health. So that's what is normal concept. So before getting into murburn concept, if you have observed the morning numbers, we are talking about nanoscale and angstrom level mechanisms. And my PhD was also somehow related to this because I never left structural biology. Especially my interest was, I am trained as a crystallographer, macromolecular crystallographer, but my interest was in the structures. So at that point of time, I developed the engineering aspects of single monomeric enzymes. What I understood is individual structures as well follow machines. Not just we are talking about ATPase, protein assemblages and natural nanotubes. Instead, even a single protein monomeric enzyme follows machines. That means it has mechanical components which are clearly flexible enough to accommodate all the stresses that go around the micro or nano environment. So same thing, I got excited with this murburn concept, and when Dr. Mukherjee was talking about this mucus, I have been with you for I think for past 4 or 5 years. We were always discussing about the ideas. The interesting thing was even in 2024 when he organized 3 days symposium at Amrita Institute. There also I came and I was involved. Then at that time also we were discussing about all these discussions went on, and I tried to understand what are the limitations of murburn concept. Why it is not included like IFI. Yes, in the morning we have heard that everything takes time, all those things. The one point which was very, which I realized should be addressed is try to create a system, whether it is computational system or an experimental system where you can test this murburn concept. So again, coming back to the whole story of this, the morning onwards we are talking about nanoscale observations and explanations or justifications and or angstrom level. Same which I did, I finally found out in my aspect project at the nanoscale and angstrom level, I found out how each compartment, each machine component is assembling itself to catalyze a particular peptide or to degrade a peptide, to cut a peptide. So I never went to the chemistry part. Here also, I am not going to the chemistry part, but I am the structural aspects I am trying to provide to this particular theory of murburn concept. which I feel I am very much excited about the potential and potential of this particular form which I will the insertion of the so we are talking about mucus and murburn and LLPS. So when he sent me the paper to look at about it, I understood what is mucus and it has a huge role. I was also inspired for students Men in Black. I always used to admire how they used to create these slimy skin-like structures. In fact, whether it was animation or really they had a manufacturing technology to create a sliminess in a particular sheets. Okay? So I was very inspired at that time, amazed at it. So when LLPS came, this also is again related to structural biology. The structural biology aspect is I went into so depth of protein 3D structures that I felt protein 3D structures should have more flexibility than what we talk about E and lock and key methods. So lock and key methods. I never believed in this lock and key method. Exactly it coincided with this. So when we were talking, I was feeling that yes, this particular theory is more realistic than the lock and key method. So when this lock and key method, I abandoned the thought from my mind. Then what is the other one? It should be very flexible. So that led to intrinsically disordered proteins. These intrinsically disordered proteins are responsible and they are so sensitive that they change their shape based on the circumstances, the context of the term. So they have multiple, they are now being called as, they can be moonlighting proteins and promiscuous proteins. So there are very terminologies that so the same sequence, 100% identical sequences can have different functions. So that is possible because of the intrinsic disorder which enables them to adapt, manifest themselves based on the requirement. So this is nature's real design principle which efficiently being used by nature for various manifestations. So this is another exciting part which again aligns with the Murburn concept. The spontaneity or stochastic nature which we expect. Now, the interesting fact of getting me into LLPS is I worked with the father of introducing disorder proteins, Dr. Peter Pompa. He is in Belgium, currently in research in Belgium. So, he and worked and published the paper. So, in that, I was invited to LLPS. So, liquid phase separation. This gave an indication that this is very important because individual molecules are not going to be, cannot explain all the phenomena that we are experiencing at the mesoscale. So, from nanoscale level, we are coming towards mesoscale. And at this mesoscale level, we are trying to understand how individual molecules together will help in a bigger phenomena at the level of cellular, the sizes and all. So that aspect, I have reached that understanding that LLPS is a phenomenon which is real, and when many macromolecules come together, there is a chance of crystallizing or aggregation happens. So interestingly, this was more interesting to me because I always looked at the application part of it, not the basic science. So this has given me an understanding that if we work on LLPS, we might even be able to try to come up with some methodologies to alleviate or to cure or to address Parkinson's disease and Alzheimer's. So it is the aggregation or the precipitation of the protein which is happening in the brain cells because of which memory losses are happening. So to this point I was not aware of Murburn concept. But LLPS, when I talked to my collaborator at that point in time, and I wrote a project on LLPS, how to computationally predict LLPS, not really knowledge at that time, but I wrote it submitted to Tribo scholarship. There is recently about this mucus, Dr. Murali sent me the draft and told, can you add something? The moment I heard mucus, it is about layers of biological macromolecules assembled as they can be compartments to create compartments, they can be barriers and all that. So then I went to the literature. How can mucus and murburn, how can we make this more physically viable to LLPS? So that's a little bit talk about it. And as you can understand, my language is very elementary because I am just getting into this subject. I am excited seeing the applications that are there. Can you imagine if we are engineering LLPS with murburn concept, we can create amniotic sacs, pregnancy related, all aspects, artificial skin and every possible it has. But whatever are currently being done, the science aspect is not as strong as what you can express or explain or justify by murburn concept. So this is what background is. From here it will be almost 10 minutes that I close this talk. Okay, so murburn concept, the most important aspect is like we are talking about, we have been listening to the individual nano or electron interactions which are happening between the reactive species that are happening in this space. But how this particular LLPS layer, the moment we introduce the LLPS as a liquid separation, how they are trying to control the redox reactions. So this is what the layers will be forming, and those layers are acting as not barriers, they are acting as redox regulators. So that is the beauty of this whole discussion. This one slide explains how this is going to work. So here you can see this is a classical method where everything is a barrier. There are one or two conduits which are allowing some reaction to happen, which is very difficult. However, in the case of murburn unified concept, where LLPS is also included, then we have a very big a more democratic system of this redox reactions to enable various other functionalities. So classification okay, so this is the classical way that is more still. In a crude way, we can talk about that, look at it as locking mechanism. Okay, so the mechanism focus on gene products, okay, and channels and membrane work. So this is the problem, the very classical view of the reactions that are happening. Trying to explain. We will hijack our So what are the limitations of classical mucus explanations? One is that definitely that, as in the morning also we have seen very clearly, energy over industry. Just last lecture talk on the family dependent persons about this. And there is high cost of mucus ECM and EPS systems far exceed basic protection needs. So, what is that? What is the classical rule? Classical rule is mucus is only for defense, protection, and only these two conditions. But it is not for protection or as defense. It is actually a regulator. So that's what is the proposed in this particular paper. And this is one thing, we are unable to match the energy required to create EPS versus the protective needs. That is one. The second is the failing to explain mesoscale phenomena. Exactly. So in the morning onwards, we have using scaling and nanoscale level interactions we have. But when it comes to mesoscale, how cell is interacting with the cellular receptors and membranes are interacting with individual molecules, it is not explainable by or we are able to extend the classical theory to address this particular answer this question. So that is another reason. Next is full integration of hydrogen physics. So we understand hydrogen as LLPS is there. Then this type of what we have observed is proteinous membraneless organs. So this is another concept which is supported by LLPS. So how these things should be explained, which are formed inside the cell, outside the cell, and they are causing a lot of diseases, many diseases, individual ones. So these are not being explained by our classical microscope. So these are the limitations. And all these things today cannot be explained. This will be able to explain the problems with nature or and we cannot predict the predictable individuals. The individuals are not justified. So that's the mental model, which is now an integrated model, which is able to take care of the energy, biometabolic cycle, and model industrial complex in various incorporates stochastic dynamics and hydrogen physics. It enables us to import the research that has been done by other domains and explain that. I will not really go through this already very well. So essentially the model concept is, let us talk about probabilistic non-deterministic in the case of methodology, and we might want to explain how methodologies are adapted to diffusible reactive species. We have produced extended and when it is coming to signaling, we are having very tiny space-based organization of the reaction. Adaptation, we have LLPS now for hydrophilic and the individual and the framework we have. So global concept is biological concept emerges from stochastic active redox chemistry, whereas this is semi-osmotic, gradient based and membrane, and it is more rigid in its expression. So this model is stand question requiring about now mucus is defined in a very crude way as hydrated polymetric phases. And when it is hydrated polymetric phases, Murburn is able to explain this to some extent. And it has many ways of it can be explained in the mucus layers and the extracellular matrix, and we have breakdown attributes. These are the parameters. So let me be more honest in this case. There are models already available which classifications also are able to model using these parameters. So I insert these parameters based on high hydration, amplitude, and these are the major layers of defining the hydrated polymer. So hydrated polymers are evolved mesoscale redox organisms. Regulators I told earlier, it is actually redox organisms that buffer yet exploit reactive species and their hybrids. So that is the opportunity we have by using this liquid phase. And why liquid? A lot of research work has gone to develop, and many computational models are developed, and many mechanisms have been described for liquid phase. What exactly is liquid? As you can see, and in the morning, Dr. Murthy defined that he's looking at the cell as a colloid. Now it has to be refined further. It is not just colloid, it is a separation of phases also. So as you can see, this is the colloid we are talking about, heterogenetically, homogenetically, but there is a remixing that happens because of the inherent properties of the molecules, especially macromolecules, and their properties, and ions and their properties. That is enabling this coacervate formation. So dense coacervate formations and the ions and the liquid-like ions. So these two are two different phases which are the output of this particular mix. So we are not at this stage, we are at this stage. So this is the LLPS, which has been studied computationally and mathematically in a very strong. So this when we are associating with the explanation given for murburn, it has very, very strong justification because we are providing the first physical demonstrable model for how murburn can work and make its reactions happen across cells or across systems, not about individual models. That's the thing. So in fact, we are understanding we have granular scale and anything models like that, and express we have mucus and now this is the LLPS and murburn shared biological ground. As you can see, we have talked about these things, and this is the LLPS aspect. This is the shared biological background on which you can develop many experiments. And in these experiments, can they be restricted only to computational or theoretical? No. Actually, we can develop these things into real experiments as well. And I have my friend, Pune, Thomas. So he developed 20 years back artificial membrane. But now it is much more efficiently you can create better enzymes or better membranes or even membraneless organelles also we can develop by engineering the concept of LLPS. So this aspect is about how we explain mucus as a result of the in various case studies. For example, causing mucus, how the causing mucus in amphibian egg. This mathematically, I think we have modeled it. I just did not go into further detail, but where my involvement was there, I was able to understand. So we have the cervical mucus, how pregnancy flux and ovulatory mucus, labor, all these things are very clearly on. We are able to explain based on the organization of the focus, oxygen and the DRS, microgradient and the exoskeleton. These are the examples of cases which we just submitted this published as a treatment in bioarchives. We are going to communicate soon. Now coming to digital analysis like the classical theory and unified developmental group, we are in the functional and incoherent LLPS provides physical architecture for adaptive regulation, hydrated polymers are mutual adaptation. This is the complete unified vertical group which strengthens the whole development concept, publishes scale analysis and many more applications which come here. So engineered murburn LLPS mucus analogs, we can have various models and develop engineered mucus for moving like that, and we can have organ that can be done, and here reproductive replacements to the mucus and the biofilm control is diagnostics and these are the applications. So the take-home message is very clear: mucus, and LLPS provides a solid bridge between explaining the phenomena and also providing a demonstrable model, physical model. So I am supposed to go a little more detail. If you have any